Hello, this is eSpin. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Introduction to AI Code Assistants. AI code assistants are software tools that use machine learning, ML, and AI algorithms to provide coding support to developers. These assistants can suggest code snippets, identify bugs, offer optimization tips, and even generate entire blocks of code based on natural language descriptions. The goal is to enhance productivity, reduce errors, and accelerate the development process. How AI code assistants work. Understanding how AI code assistants work involves exploring the underlying technologies and mechanisms that enable them to assist developers effectively. These tools leverage a combination of machine learning, ML, natural language processing, NLP, and deep learning to perform their tasks. Key technologies behind AI code assistants include machine learning, ML, natural language processing, NLP, deep learning, code repositories and documentation, contextual awareness. Next page are detailed look explanation at the processes and technologies that power AI code assistants. How AI code assistants work. AI code assistants work by leveraging machine learning, natural language processing, and deep learning to understand the context of the code and provide intelligent suggestions, error detection, and code generation. They analyze vast datasets of code and use advanced algorithms to assist developers in writing, debugging, and optimizing their code in real time. Key technologies behind AI code assistants. AI code assistants utilize key technologies such as machine learning, natural language processing, and deep learning to analyze code, understand context, and provide intelligent coding assistance. Machine learning. Machine learning in AI code assistants involves training models on vast datasets of code to recognize patterns, predict developer actions, and offer relevant coding suggestions. There are two types of machine learning models, which is training data and pattern recognition. Training data. AI code assistants are trained on vast datasets of code from various sources, including open-source repositories, documentation, and educational resources. This training data includes code snippets, entire projects, and even natural language descriptions of code functionality. Pattern recognition. Through machine learning, the AI models learn to recognize patterns and structures in the code. This enables them to predict what the developer might want to write next, based on the context of the current code. Natural language processing. Natural language processing enables AI code assistants to interpret and translate natural language descriptions into code, understanding the context and intent behind developers' inputs. There are two types of natural language processing, which is understanding context and translation. Understanding context. Natural language processing allows AI code assistants to understand the context of the code and any natural language inputs from the developer. For example, a developer might write a comment describing the functionality they need, and the AI can generate the corresponding code. Translation. Natural language processing helps in translating natural language queries or descriptions into code. This is particularly useful for generating boilerplate code or implementing common functions. Deep learning. Deep learning uses neural networks to process and understand complex patterns in code, enabling AI code assistants to provide accurate and context-aware suggestions across various programming languages. There are two types of deep learning, which is neural networks and contextual understanding. Neural networks. Deep learning models, particularly neural networks, are used to process and understand complex code structures. These models can handle various programming languages and frameworks, making them versatile. Contextual understanding. Deep learning enhances the AI's ability to maintain context over longer segments of code. This is crucial for providing relevant suggestions and generating accurate code snippets. Code repositories and documentation. AI code assistants integrate with code repositories and access documentation to provide relevant examples, explanations, and code suggestions based on real-world coding practices. There are two types of code repositories and documentation, which is integration with repositories and documentation access. Integration with repositories. AI code assistants often integrate with code repositories like GitHub. This allows them to access a wealth of real-world code examples, which they use to improve their suggestions. Documentation access. These assistants can pull in relevant documentation to help developers understand how to use specific libraries or functions. This is done by parsing and summarizing documentation from various sources. Contextual awareness. Contextual awareness in AI code assistants refers to their ability to understand and consider the broader context of a project, including dependencies, libraries, and the current state of the code, to provide relevant and accurate suggestions. There are two types of contextual awareness, which is project scope and state management. Project scope. Advanced AI code assistants are aware of the broader project scope, including dependencies, libraries, and previous code. This awareness helps them make more accurate and relevant suggestions. State management. Maintaining the state of the current development environment is crucial. The assistant keeps track of the current file, open tabs, and even the project's build configuration to provide context-aware assistance. Functionalities enabled by AI code assistants include code completion and autocomplete, error detection and debugging, code generation, code refactoring. Next page are detailed explanation at functionalities enabled by AI code assistants. Functionalities enabled by these technologies. These technologies enable AI code assistants to offer functionalities like code completion, error detection, code generation, refactoring, and contextual documentation, enhancing the overall coding process. Code completion and autocomplete. Code completion and autocomplete features in AI code assistants predict and suggest the next part of the code as developers type, speeding up coding and reducing errors by understanding the context and recognizing patterns. There are two types of code completion and autocomplete, which is predictive text and snippets and templates. Predictive text. By understanding the context and recognizing patterns, AI code assistants can predict and suggest the next part of a code line. This reduces the amount of typing required and minimizes syntax errors. Snippets and templates. The AI code assistant can suggest entire code snippets or templates based on common patterns, such as loops, conditionals, or class definitions. Error detection and debugging. AI code assistants enhance error detection and debugging by identifying syntax errors and potential bugs in real time and suggesting fixes based on patterns in code analysis. There are two types of error detection and debugging, which is syntax checking and bug identification. Syntax checking. AI code assistants can detect syntax errors in real time, highlighting issues as the developer types. This immediate feedback helps in maintaining code quality. Bug identification. By analyzing code patterns and structures, the assistant can identify potential bugs or logical errors. It can suggest fixes or highlight problematic areas for the developer to review. Code generation. Code generation involves creating code automatically based on developer input, such as natural language descriptions or templates, to streamline development and reduce manual coding efforts. From natural language. Developers can describe a function or a piece of logic in natural language, and the AI assistant can generate the corresponding code. This is particularly useful for implementing standard algorithms or boilerplate code. Template-based generation. The AI code assistant can provide templates for common coding tasks, such as setting up a new API endpoint, configuring a database connection, or creating a user authentication system. Code refactoring. Involves improving the structure, readability, and efficiency of existing code without changing its external behavior, often through suggestions like renaming variables, optimizing loops, or restructuring code. Optimization suggestions. AI code assistants can suggest optimizations for existing code, such as improving loop efficiency, reducing complexity, or enhancing readability. Renaming and restructuring. The AI code assistant can suggest renaming variables, functions, or classes to follow naming conventions and improve code clarity. It can also recommend restructuring code to adhere to best practices. Workflow of an AI code assistant include initialization, context analysis, user input, real-time assistance, continuous learning, and proactive recommendations. Here's a step-by-step detailed explanation workflow of how an AI code assistant typically operates. Step 1 is initialization. The assistant loads the current project, including all files, dependencies, and configurations. It then initializes its models and prepares to provide real-time assistance. Step 2 is context analysis. The assistant analyzes the current context, including the open file, cursor position, and recent changes. It then identifies the programming language, libraries, and frameworks in use. Step 3 is user input. As the developer types, the assistant monitors the input and offers suggestions for code completion, error correction, and documentation. If the developer inputs a natural language description or a comment, the assistant interprets it using NLP and generates the corresponding code. Step 4 is real-time assistance. The assistant provides real-time feedback, highlighting syntax errors, suggesting code completions, and offering documentation snippets. It then maintains contextual awareness, ensuring that suggestions are relevant and accurate. Step 5 is continuous learning. The assistant continuously learns from the developer's actions, adapting its suggestions based on the developer's preferences and coding style. It then updates its models with new data from code repositories, documentation, and user interactions. Step 6 is proactive recommendations. In addition to responding to user input, the assistant proactively suggests improvements and optimizations. It then identifies potential issues before they arise, such as workflow of an AI code assistant. Involves initializing the project environment, analyzing the context, providing real-time coding suggestions and error detection, and continuously learning from the developer's interactions to improve its assistance. Initialization. The AI code assistant loads the current project, including all files, dependencies, and configurations. It initializes its models and prepares to provide real-time assistance. Context analysis. The AI code assistant analyzes the current context, including the open file, cursor position, and recent changes. It identifies the programming language, libraries, and frameworks in use. User input. As the developer types, the AI code assistant monitors the input and offers suggestions for code completion, error correction, and documentation. If the developer inputs a natural language description or a comment, the assistant interprets it using NLP and generates the corresponding code. Real-time assistance. The assistant provides real-time feedback, highlighting syntax errors, suggesting code completions, and offering documentation snippets. It maintains contextual awareness, ensuring that suggestions are relevant and accurate. Continuous learning. The assistant continuously learns from the developer's actions, adapting its suggestions based on the developer's preferences and coding style. It updates its models with new data from code repositories, documentation, and user interactions. Proactive recommendations. In addition to responding to user input, the assistant proactively suggests improvements and optimizations. It identifies potential issues before they arise, such as deprecated functions, security vulnerabilities, or performance bottlenecks. Key features of AI code assistants. Key features include code completion and autocomplete, error detection and debugging, code generation, code refactoring, documentation and examples, and integration with development tools. Key features of AI code assistants. AI code assistants offer key features like code completion, real-time error detection, code generation from natural language, refactoring suggestions, and seamless integration with development tools to enhance productivity and reduce coding errors. Here's an in-depth look at the key features these tools offer. 1 is code completion and autocomplete. Involve predicting and suggesting the next part of a code line based on context, reducing typing effort, and minimizing errors for developers. Predictive typing. AI code assistants use machine learning algorithms to predict the next part of a code line as the developer types. This feature significantly reduces the number of keystrokes required, allowing developers to write code more quickly and efficiently. By analyzing the patterns in the code, these assistants can suggest the most likely variables, methods, or classes that fit within the current context. This not only speeds up the coding process but also minimizes the chances of syntax errors. Context-aware suggestions. AI code assistants offer suggestions that are highly relevant to the current context of the code. They understand the variables, functions, and libraries that are in use, and their suggestions are tailored accordingly. For example, if a developer is working within a specific framework, the assistant might suggest functions or methods that are commonly used in that framework. This contextual awareness helps in maintaining consistency across the codebase and ensures that the code adheres to best practices. Key features 2 is error detection and debugging. Provides real-time identification of syntax errors and potential bugs, offering immediate feedback and suggestions to help developers fix issues as they code. Real-time error detection. One of the most powerful features of AI code assistants is their ability to detect errors in real time. As developers write code, these tools scan for syntax errors, potential bugs, and inconsistencies. When an error is detected, the assistant provides immediate feedback, often suggesting corrections or pinpointing the exact location of the problem. This real-time feedback loop allows developers to address issues as they arise, rather than spending time later in the development cycle debugging. Debugging assistance. Beyond simple error detection, AI code assistants can also assist in debugging more complex issues. By analyzing the code, these tools can identify logical errors or runtime issues that might not be immediately apparent. They might suggest specific lines of code that could be causing a problem or recommend changes to improve the overall logic of the code. In some cases, the assistant might even generate alternative code snippets to resolve the issue, saving developers significant time and effort. Key features 3 is code generation. Allows developers to input natural language descriptions or select templates, and the assistant automatically generates the corresponding code, streamlining the development process. Natural language to code. AI code assistants can translate natural language descriptions into code. For example, a developer might describe a function in plain English, such as create a function to calculate the factorial of a number. The AI assistant can then generate the corresponding code based on this description. This feature is particularly useful for developers who are prototyping or need to quickly implement a specific functionality without diving into the syntax and structure of the code. Boilerplate code generation. Developers often need to write repetitive code for common tasks, such as setting up a server, connecting to a database, or creating a user interface. AI code assistants can automate this process by generating boilerplate code that serves as a starting point. This pre-generated code can then be customized to fit the specific requirements of the project. By automating the creation of boilerplate code, developers can focus on the unique aspects of their project rather than getting bogged down in repetitive tasks. Key features 4 is code refactoring. Involves suggesting improvements to existing code, such as optimizing performance, enhancing readability, and restructuring code to adhere to best practices. Optimization suggestions. AI code assistants can analyze existing code and suggest improvements to optimize performance and efficiency. This might include recommendations for optimizing loops, reducing unnecessary computations, or improving memory usage. The assistant's suggestions are based on best practices and can help ensure that the code is not only functional but also efficient and scalable. By continuously refining the code, developers can maintain high standards of quality and performance throughout the project. Code restructuring. Suggest ways to restructure code to improve readability and maintainability. This might involve renaming variables, functions, and classes to follow naming conventions or reorganizing code blocks to make them more intuitive. By making these suggestions, the assistant helps developers write code that is easier to understand and maintain, which is especially important in large projects with multiple contributors. Key features 5 is documentation and examples. Provides developers with context-aware documentation snippets and real-world code examples, helping them understand and implement specific functions or libraries efficiently. Contextual documentation. AI code assistants provide access to relevant documentation based on the code being written. For example, if a developer is using a specific function or library, the assistant might offer documentation snippets that explain how to use it correctly. This feature is particularly useful for developers who are working with unfamiliar technologies or need a quick reference without leaving their development environment. By having documentation at their fingertips, developers can work more efficiently and reduce the time spent searching for information. Code examples. AI code assistants can offer real-world examples of how to implement specific features or functions. These examples are often drawn from code repositories and knowledge bases, providing developers with proven solutions to common problems. By studying these examples, developers can learn best practices and avoid common pitfalls, accelerating their learning curve and improving the overall quality of their code. Key features 6 is integration with development tools. Allows AI code assistants to seamlessly work within popular IDEs and version control systems, enhancing the coding experience by providing context-aware support and tracking code changes throughout the development lifecycle. IDE integration. AI code assistants are designed to integrate seamlessly with popular integrated development environments, IDEs, such as Visual Studio Code, JetBrains, and Eclipse. This integration allows the assistant to provide in-context support directly within the developer's existing workflow. Whether it's offering code suggestions, detecting errors, or providing documentation, the assistant operates within the familiar environment of the IDE, making it a natural extension of the developer's toolset. Version control systems. AI code assistants also integrate with version control systems like Git, allowing them to understand the history and evolution of a project. This historical context enables the assistant to offer more informed suggestions, taking into account the changes that have been made over time. For example, if a certain function has been modified multiple times, the assistant might suggest an approach that aligns with the project's overall direction. By leveraging version control data, AI code assistants. Benefits of using AI code assistants. The benefits include increased productivity, reduced errors, learning and skill development, consistency, and best practices. Benefits of using AI code assistants. AI code assistants boost productivity by automating routine tasks, reduce errors through real-time feedback, and help developers adhere to best practices, ultimately speeding up the development process and improving code quality. Increased productivity. By providing intelligent suggestions and auto-completing code, these tools allow developers to write code faster and with fewer keystrokes. This leads to a more streamlined development process, where developers can allocate more time and mental energy to higher-level design, problem-solving, and innovative tasks. The reduction in manual, repetitive work not only accelerates development cycles but also decreases the cognitive load on developers, enabling them to focus on creating value and solving complex problems. Reduced errors. One of the key advantages of AI code assistants is their ability to catch errors early in the development process. By continuously analyzing code as it's written, these tools can detect syntax errors, logical inconsistencies, and potential bugs in real time. Early error detection minimizes the likelihood of these issues making it into the production environment, where they could cause more significant problems. As a result, the overall quality of the software is improved, leading to more stable, reliable, and secure applications. This reduction in post-deployment bugs also reduces the time and resources needed for testing and debugging, contributing to a smoother development process. Learning and skill development. They provide real-time feedback on coding practices, offer suggestions for improvements, and present examples of how to implement specific functions or features. This hands-on, interactive learning experience accelerates the learning curve, enabling less experienced developers to quickly improve their coding skills. Over time, the continuous exposure to best practices and efficient coding techniques can help junior developers evolve into more proficient and confident programmers, benefiting both their personal development and the overall quality of the projects they work on. Consistency and best practices. Maintaining a consistent code base is crucial for large projects, especially those with multiple contributors. AI code assistants help enforce coding standards and best practices by suggesting improvements and encouraging adherence to established guidelines. This ensures that the code remains uniform, readable, and maintainable across the entire project. Consistent code is easier to review, test, and extend, which is particularly important in collaborative environments. By promoting best practices, AI code assistants help in reducing technical debt, making the codebase more scalable and easier to manage in the long term. Challenges and limitations to AI code assistants. Challenges and limitations include accuracy and reliability, privacy and security, complexity of setup, and dependence on training data. Challenges and limitations to AI code assistants. AI code assistants face challenges and limitations such as potential inaccuracies in suggestions, data privacy concerns, complexity in setup, dependence on training data quality, and the risk of developers becoming overly reliant on the tool, potentially affecting their coding skills. One is accuracy and reliability. While AI code assistants are powerful tools, they are not infallible. The models underlying these tools can occasionally generate incorrect or suboptimal suggestions. This is especially true in complex scenarios where the AI might misinterpret the context or make assumptions that don't align with the developer's intent. Relying too heavily on AI-generated code without proper validation and review can introduce errors or inefficiencies into the codebase. 2 is privacy and security. These tools often require access to a project's code to provide relevant suggestions, which raises the risk of exposing sensitive information. For example, if the AI assistant is cloud-based, there is a potential for data breaches or unauthorized access to the codebase. Additionally, the data used by the AI assistant could be logged, stored, or analyzed in ways that compromise confidentiality. Ensuring that sensitive information remains protected and that the AI tool adheres to strict data privacy and security standards is crucial. 3 is complexity of setup. Implementing and configuring AI code assistants can be a complex and time-consuming process, particularly for large-scale projects with numerous dependencies. These tools need to be integrated seamlessly with existing development environments, version control systems, and CI/CD pipelines to be truly effective. Developers may encounter challenges in tuning the AI to fit their workflow, which can be particularly frustrating if the assistant is not delivering the expected value. 4 is dependence on training data. For instance, if the training data predominantly features certain programming languages, frameworks, or coding styles, the AI might struggle to provide relevant suggestions for other languages or less common use cases. This can lead to biased or suboptimal recommendations, particularly in niche or highly specialized projects. Furthermore, outdated training data can result in the AI code assistant missing out on newer technologies or practices, reducing its usefulness. Future prospects to AI code assistants. Future prospects include improved contextual understanding, advanced debugging capabilities, cross-language support, and proactive assistance. Future prospects to AI code assistants enhanced contextual understanding, advanced debugging capabilities, cross-language support, proactive assistance, and improved collaboration features, making them increasingly integral to the software development process. Future prospects. 1 is improved contextual understanding. Future AI code assistants will have better contextual awareness, understanding the project's broader scope and making more relevant suggestions. 2 is advanced debugging capabilities. AI assistants will become more adept at identifying and fixing complex bugs, even those involving multiple components and dependencies. 3 is cross-language support. As programming environments become more heterogeneous, AI code assistants will support multiple languages and frameworks seamlessly. 4 is proactive assistance. Instead of merely responding to input, future AI assistants will proactively suggest improvements and optimizations, identifying potential issues before they arise. Case studies and applications. Case studies and applications to AI Code Assistant include GitHub Copilot and Tab 9. Case studies and applications of AI code assistants, such as GitHub Copilot and Tab 9, demonstrate their ability to significantly boost developer productivity by providing intelligent code suggestions, error detection, and contextual documentation across various programming languages and environments. Number 1 is GitHub Copilot. GitHub Copilot is one of the most prominent AI-powered code assistants, developed through a collaboration between GitHub and OpenAI. It uses OpenAI's Codex model to provide real-time code suggestions directly within the developer's integrated development environment, IDE. The key features of GitHub Copilot consist of code generation, wide language support, and context-aware suggestions. First key features is code generation, which GitHub Copilot excels at generating code snippets and boilerplate code based on natural language prompts or existing code context. This ability to quickly generate reusable code significantly reduces development time and allows developers to focus on more complex and creative aspects of coding. Second key features is wide language support, which Copilot supports a broad range of programming languages, making it versatile for developers working on different types of projects. Third key features is context-aware suggestions, which the tool understands the context of the code being written and provides relevant, in-context suggestions that align with the developer's intent. Impact on development of GitHub Copilot. By integrating deeply into popular IDEs like Visual Studio Code, GitHub Copilot helps streamline the coding process, offering valuable time savings and reducing the cognitive load on developers. However, while Copilot is highly effective, developers must remain aware of potential inaccuracies and ensure that generated code aligns with project-specific requirements. Number 2 is Tab 9. Tab 9 is an AI-driven code completion tool that leverages machine learning to provide intelligent code suggestions. It is designed to work seamlessly with multiple programming languages and integrates well with popular IDEs like Visual Studio Code, JetBrains, and more. The key features of Tab 9 consist of predictive code completions, language support, and IDE integration. First key features is predictive code completions, which Tab 9 provides autocomplete suggestions as developers type, predicting the next part of the code based on the context and patterns learned from previous code. Second key features is language support, which it supports multiple programming languages, making it adaptable for various development environments. Third key features is IDE integration, which Tab 9 integrates with a wide range of IDEs, providing in-context support that aligns with the developer's workflow. Impact on development of Tab 9. Tab 9 enhances coding efficiency by reducing the number of keystrokes needed to write code, allowing developers to focus on solving more complex problems. Its adaptability across different languages and environments makes it a valuable tool for diverse development teams. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.